Good evening and welcome to NASA's Wallops Flight Facility in Virginia for a post-launch news conference for Northrop Grumman's 11th Commercial Resupply Services mission to the International Space Station. The Cygnus spacecraft, filled with 7,600 pounds of research, crew, supplies, and hardware, launched today at 4:46 p.m. Eastern Time on an Antares rocket from Pad 0A at Virginia Space's Mid-Atlantic Regional Spaceport. I'm Stephanie Shearholtz of NASA's Office of Communications, and I'm pleased to be joined this evening by Joel Montalbano, Deputy Manager of the International Space Station Program.
Good evening.
Kurt Eberly, Antares Vice President at Northrop Grumman. And, oh, there's Kurt. And Frank DeMauro, Vice President and General Manager of Space Systems at Northrop Grumman. Thank you for joining us this evening after a great afternoon launch today. We'll start with opening comments from our guests, and then we'll take your questions. Joel?
Well, huge congratulations to the Northrop Grumman team. Beautiful day, a fantastic launch. It's great to have another cargo vehicle on its way to the International Space Station. The Cygnus is on a rendezvous plan that will result in a capture of the vehicle Friday morning, approximately 5:30 Eastern Time. The astronaut whose prime responsibility to capture the spacecraft will be Anne McLean. She'll be backed up by David from the Canadian Space Agency. This vehicle carries 7,600 pounds of hardware, utilization, research, vehicle hardware, crew supplies that we're looking forward to seeing on board the International Space Station. We talked prior at the pre-launch press brief that this was the first mission where we had the capability to do late load at launch minus 24 hours. From a NASA standpoint, that went extremely well. We're looking forward to this capability for future Cygnus missions, and it's another example of what we're doing to increase the science and utilization that we can accomplish on board the International Space Station. So we want to thank the Northrop Grumman team and everyone involved for making that possible. We talked also in the pre-launch briefing that this was the last mission in Northrop Grumman's cargo resupply contract. And so throughout that contract, the company, Northrop Grumman, has delivered approximately 30,000 kilograms or 65,000 pounds to the International Space Station. To put that in a little different perspective, that's about the equivalent of delivering 10 elephants to the International Space Station. So a huge amount of effort that's been accomplished between the Northrop Grumman team and the NASA team. And, you know, throughout these missions, we've learned to work together. We've learned what it takes to enhance the research and the utilization on board the International Space Station. It's a pleasure to work with these guys, and we look forward to working with them for a long time in the future. With that, I'll hand it over to Kurt.
Thank you, Joel. Well, what a great launch. I'm super proud of the Antares team. They've worked extremely hard over the last 6 months putting this vehicle together. Can't say enough about the dedication and professionalism of our team. Just outstanding. They get right on console, and it's like they're just back in the swing of things from the last launch. So, great job. Heaviest launch to date. The new cargo loading system that Joel alluded to worked just as planned. So yesterday we lowered the vehicle after having gone out earlier, raised the vehicle up to vertical, did our combined systems test. Then we lowered the vehicle back down to horizontal, brought the mobile clean room over the front, and removed the pop top off the front of the fairing and gained access to Cygnus. That all went really well, just like we had practiced it last summer. So we're really excited to bring that capability forward into the system here. Countdown was very smooth today. I spent a fair amount of time just listening on back nets for any issues, and really didn't have any. There was one you may have heard about where we had a GN2 purge issue where we purge all of our electrical boxes, junction boxes and so on, and one of them on the transporter erector launcher, the TEL, had a negative indication that the purge was flowing, but we could tell from other data on the ground systems that we thought the nitrogen was flowing, so we sent the red team out there just to check it out, and they confirmed that the purge was flowing, and so we decided we would ignore that sensor input if it went red again. So that was really the only issue we were working. You may have heard the red team go out there, and then they got back in plenty of time, and so there was really no delays from their operation. And that's why we have them on island, ready to go out and inspect something or make a change on the launch pad. The orbit. Well, why don't we? I understand we have a video of the launch, and that's more fun than listening to me talk. So let's roll that.
5, 4, 3, 2, 1. We have engine ignition.
So there you see the
Antares NG-11 mission to the ISS engines at full power.
We ignite the engines, and at the 47% throttle, we do a quick health check on each engine, automated. If that passes, we release the rocket, we rock back that transport erector launcher, which also serves as our umbilical mast, and we throttle up all at the same time. It takes a couple seconds for thrust to exceed mass, and then we lift off. And here we are, we're getting up towards max Q on this version of the rocket, the 230. We throttle back at max Q to reduce the structural loads on the vehicle, particularly the bending loads. And then after about 18-second throttle notch down to 55%, we crank it back up to 100% for the rest of stage 1 burn. And then as the vehicle starts to consume the propellants towards the end of stage 1 burn, the axial Gs crank up pretty high. So that's when we start a tail off on the throttle to keep the Gs around a little over 4 Gs, 4 to 4.5 Gs, which is an agreement we've reached with Cygnus on limiting the axial acceleration. I'm telling you this because the next mission, one of the things we're going to do on NG-12 is we're going to lift more cargo into orbit, more total mass, and one of the ways we're going to do that is to eliminate that throttle notch, and so we're making the first stage. And so for NG-12, we'll be able to fly 100% throttle throughout the first stage burn. So here we are. It's about 3.5 minute burn on stage 1. You can see stage 1 is getting towards the end. We're pitched over and adding a lot of tangential speed around the Earth, which is what you need to get into orbit.
Engines remain nominal. Attitude and power systems all look good.
As I mentioned, we throttled down on a ramp to keep acceleration constant. And we're sensing propellant consumption in each of the tanks, the RP tank and the LOX tank, and we make adjustments to the mixture ratio on the engines to try to achieve simultaneous depletion. That all worked very well. We had great performance out of stage 1 and got all the energy we needed out of it. Then stage 2 took over, separated the fairing. The pop-top changes were no issue for fairing separation. Then we ignited stage 2. That burned for several minutes. We burn out stage 2. We do a 2-minute settling period, and then we separated Cygnus. Cygnus was right in the box at 201 by 291 kilometers and inclined 51.646, so that's right within requirements. Very good orbit. And then 265 seconds after we separated Cygnus, we then started separating the secondary payloads, the ThinSats and the 3U CubeSat called SASE, and that was, each of those deployments was spaced out by 10 seconds. So we separated 60 spacecraft. They're tied together in some strings. So there's 60 total ThinSats. These are the educational satellites built by students, designed by students. And we have word from Virginia Space that 43 of those 60 have been transmitting data, and they've received data from. They expect to get all of them. It just takes a while for all of them to get oriented properly and start communicating. So that's great news. And then the 3U CubeSat SASE is due to start transmitting at around 11:30 tonight. So we really wish all these young experimenters the best of luck with their mission here in orbit. Hope to get some great data. And with that, I'll turn it over to Frank.
All right, thank you, Kurt, and let me thank the team, your team, for a great launch. The spacecraft was placed in a fantastic orbit by Antares. So thanks to the Antares team, the Wallace team, the range, and certainly our partners and customer at NASA, JSC, and the ISS Program Office for all the support along the way. So fantastic launch. The spacecraft is very healthy. It's performing very well. We received good communications right off the rocket, And that's because we always plan for the expected insertion orbit that we get from Antares, and on orbit we can point the antennas where we think the spacecraft is going to be, and Antares put us in the perfect orbit right where we thought it was going to be, and so the comms started right off that we were getting telemetry off the spacecraft, so that was great. Then we initialized the propulsion system and the guidance and navigation system, and they took over and started to control the spacecraft. We have rather large batteries on the spacecraft, so we can do all that before we deploy the solar arrays. There was something that we did a little bit differently on this mission. We did something that we call a targeted altitude burn. We actually did 2 of them, and this is a new capability that Cygnus has, that wherever Antares puts us off, the spacecraft on its own figures out where it is, the computer figures out where it wants to be, and the spacecraft does a couple of orbit-raising maneuvers without us having to touch it. And those went extremely well, and that's something that we're going to be using more and more as we go into CRS-2, and the spacecraft is heavier, and that system worked flawlessly. Then we deployed the solar arrays. I can report that they are both out fully successfully and generating all sorts of great power. So now those big batteries are getting recharged, and the spacecraft is healthy. We're currently went from the orbit that Kurt talked about of about 200 kilometers by 290. We're currently at about 300 kilometers by 380 kilometers. So those 2 targeted altitude birds that we've already done have raised the orbit over 100 kilometers on their own. And so now with the spacecraft will perform the rest of the orbit raising with the team on the ground to get us to phase our orbit for a Friday morning rendezvous with the space station. We're going to get ourselves to where we're about 1,000 meters below the space station, and then we'll start our slow trek upward towards the space station, which is about 410 kilometers or so in altitude. And we'll do that starting at the late hour in the Eastern time on Thursday, tomorrow night, and then we'll get close to the station sometime Friday morning, where we'll get to about 10 meters below the ISS, and then the crew will grapple us and then eventually berth us to the ISS. So we're really excited about that. So the reality is we're going from launch to being on the ISS in about a day and a half, and one of the things that enables us to get there so quickly is those target altitude burns that I mentioned before. So if you think about the 2 things that we've done to shorten that time frame from when we can put the payloads in to the spacecraft 24 hours before launch, and then this new system that will get us to the station a little bit faster, we're really shortening the time from when NASA puts their science in Cygnus to where the crew can actually take that science out and start running the experiment. So we're really excited about showing those capabilities on NG-11 and getting prepared for CRS-2 and the NG-12 mission that we'll do later this year. So just to recap a few of the first we've done, and to add a couple more, because I think it's important as we increase the capability of the spacecraft and the rocket to point those out. So we've talked about the rodents. We've flown the rodents for the first time. They arrived yesterday afternoon, as you heard at the press conference. The final load cargo that went in 24 hours before launch went extremely well. The system that the Antares team put together worked flawlessly. The Cygnus team did a great job accessing the vehicle, opening the hatch, inserting the cargo, and then closing the hatch, doing their purges, and then closing up the system, and then the Antares team putting the rest of the fairing on, and then rotating back vertical. All that went extremely well, and actually a little bit ahead of schedule, so we're encouraged by that. Another couple of things that we haven't really talked much about. We have increased on this mission the amount of telemetry and commanding interface we have with the scientific payloads. So the rodent enclosures that we installed on the vehicle 24 hours, we're getting a lot of telemetry. We're seeing how the rodents are doing. We're measuring the temperature in the enclosure, the amount of CO2, the amount of oxygen. We're seeing when the fans turn off to scrub the CO2 out of the system and when oxygen is being put into the habitat enclosure. So that's new on this mission. And then I talked about the target altitude burns that we're happy went so well. So the Cygnus is in great shape. We're looking forward to getting to the ISS on Friday, delivering our cargo, and of course the scientific experiments and continuing to support that. One of the special things about these vehicles, when they arrive and they open the hatch, we become part of the space station for as long as we're there. So we'll be there for 3 months, and then after which, of course, as we've talked about, we plan to do our post-departure program where we'll release our CubeSats from both the Canarex CubeSat deployer and the Slingshot, and then we'll begin our extended duration mission with our updated attitude control system. So it's been a great day, great launch by Antares. So for the Cygnus team, it's just the beginning of what we're sure to be a great mission.
Excellent. We'll now take questions. And so please be sure you raise your hand, wait for the microphone, identify yourself and your outlet, and to whom you're directing your question. Tarek?
Thank you very much. Tarek Malik from Space.com. I have, I think, a quick one for Joel and then one for Frank. Joel, it's almost Easter, and I'm just curious, amidst all the science and gear, if there are any Easter goodies for the crew on the station for Cygnus. And then for Frank, it seems like even though this is the last flight of the CRS-1 program, that there's a lot of new stuff on Cygnus here. And I'm curious how that evolution has been for the vehicle and what it means for the second program coming up with the next flights. Thank you.
So from an Easter standpoint, we've delivered 3,500 pounds of science and utilization hardware for the crew to work on. We don't have anything special. You know, we've been asked a couple questions, is there an Easter dinner or any special food? We didn't find any special food on this mission, but the standard menu that we have on board has things like turkey, has shrimp cocktail, has pork, has candied yams, all sorts of desserts. So I can tell you that the crew will have a pretty good Easter.
And I think on the Cygnus capability evolution, if we think back to when we first started launching Cygnus, we could fly about 2,000 kilograms of cargo, and that was really the focus of those missions. And since that time, if we think about the timeline starting on what was OA4 at the time, we went to our enhanced Cygnus where we could carry a lot more cargo. We increased the amount of cargo by about 75%. With only a 33% increase in cargo volume. We added the UltraFlex solar arrays and all sorts of other mass savings issues, and so we were able to turn Cygnus mass into cargo mass, and that was a big upgrade to the system. And on OA9, we switched out the communication system to the ISS to the C2V2 system, and at the same time, we added much more capability in terms of electrical interfacing to secondary payloads that we can fly. And now on NG-11, we have added the rodent capability, the command and telemetry capability, the other things, the late load, the target altitude burns, a lot of that in preparation for moving into the CRS-2 contract. In reality, the rodents, the late load, the pop-top fairing for Antares, the targeted altitude burns, they were things that were actually we were slated to do on our first CRS-2 mission on NG-12. But we decided, working closely with our NASA partners, to actually move those capabilities forward, to give NASA that capability sooner, give us the ability to check it out ahead of the CRS-2 contract. And so it's been an investment on both Northrop Grumman's side as well as NASA's side in growing those capabilities. And so it's been a steady flow of adding different sensors to the vehicle, but primarily focusing on giving NASA more and more capability with each mission, and I think it's gone extremely well. We're very proud of what's been accomplished.
Ken?
Hi, thank you. Ken Kramer, Space Up Close. And thanks for the daylight launch. So it was spectacular to see that after 4 night launches. Thank you. So looking to the future, my question for you guys. What are the improvements now you're going to do, the changes in the contract for CRS-2? What's different? And probably more for Frank, but maybe, how can you guys contribute to landing people on the moon with Cygnus and to the Gateway in 2024? Are you proposing to send this like as a cargo ship to the Gateway, or how can Cygnus contribute to landing people on the moon in 2024? Thanks.
Okay. You want to start?
Sure. I think there's 3 big requirements for CRS-2 that drive changes on Antares. First is more mass. So we're going to carry more mass to orbit. Part of that's more cargo, and part of that is just a heavier Cygnus to accomplish all the things that we need to, that Cygnus needs to do to meet the CRS-2 requirements, as Frank said, you know, faster rendezvous and more powered payloads, things like that. So on Antares, I mentioned during the playback that we're gonna add some metal in 2 key locations, the intertank bay and the forward bay of the Stage 1 core. That's going to allow us to fly 100% throttle throughout first stage burn. We're also going to allow the axial Gs to go up higher than they are right now. We've done all the work to make sure the rocket can survive that, and Cygnus can survive that as well. That will net us the performance increment we need to allow the higher cargo that we're going to carry on CRS-2 and meet all those requirements. We also have cargo flexibility, mass flexibility. That means NASA will be able to, at 24 hours before launch, tell us, hey, I don't want that cargo on the spacecraft, and pull off up to 750 kilograms of mass. They'll be able to change the manifest that late, and we will upload the total mass on day of launch. That'll be a parameter that we upload. You may have heard it today. We practiced it on NG10 in our software, and we practiced it again today, that mass flexibility. Now, NASA didn't need to do that. Everything that they planned to fly, they flew. But in the future, there could be cases where they want that flexibility, and we're gonna have that available. And then the third thing is just the late load, the cargo load at 24 hours. And so we were able to demonstrate that today. Worked very well. So glad to see that. It was a great effort to invest in the GSE and the mobile clean room and all the changes we need to make to the pad, where we're leaving most of the commodity lines hooked up when we go from vertical back to horizontal. We've sped up the time that we rotate from horizontal to vertical. All sorts of little changes like that have contributed to this entire timeline that enables the 24-hour late load. So those are the primary change. Oh, one other thing. So there's the 24-hour late load. There's also the ability, if we scrub for whatever reason, to be able to go back down horizontal, provide access to the payload if NASA wants to refresh it, and then go back up vertical. So for CRS-2, that will be within 24 hours if we scrub before fueling. Yeah, so that's another. Those are the 3 main driving requirements that have prompted the investments and the improvements in Antares. So, Frank?
Yeah, so if we look to the future, obviously we've got a great team that's going to continue focusing on making sure Cygnus successfully and reliably flies to the space station and delivers the cargo and the science. But if you look at the capabilities that we know we have using Cygnus as a building block, Cygnus can be used for logistics out to cislunar space. It can be used from a utilization standpoint. It can be used as an habitat or as a science module. We can also provide power and propulsion to the Deep Space Gateway out in cislunar space. And then you put on top of that our combined capabilities with Northrop Grumman and their legacy company. We can even expand that further and be part of the system to put people on the moon itself. Grumman, of course, built the lunar landers for the Apollo mission. Northrop Grumman designed the Altair lander, a part of the Constellation program, which of course was canceled before it flew. And so if you look at that expertise and you combine it with our expertise with Cygnus, we know there is a lot of capability out there that we're going to take advantage of. So we have every expectation that we're going to play a large role, not only in supporting crew that goes out to the moon, but being able to design, build, and deliver something that actually brings people down to the moon. So we're so excited about that future. And when NASA came out and said, we want to get people on the moon to 2024, we were extremely motivated and happy to hear that. We're ready to go.
And I'll just add, you know, we use space station a lot in addition to utilization research we're using it as a technology test bed for exploration. This vehicle carries some life support equipment that we'll test on board ISS and use for the future. I mean, we have some work to do on our life support system that we want to optimize and, you know, take what we have today, make it even smaller so that we can go further and leave low Earth orbit. So together we work, and we'll go make this exploration project work.
Thank you.
Great. I see a question over there.
J.D. Taylor, USA in Space for Northrop Grumman. Do you all see using Wallops more launches in the future, or do you see them tapering off or using other sites? So what's your plans for Wallops?
Well, for Antares, we only have the one launch pad here. It's quite an investment by Virginia Space, and so we're really happy with the spaceport and the service we get here. We don't have another launch pad that we've invested in at this time. So yeah, we'll be launching out of Wallops. We will continue these CRS flights into the future. We'd love to win additional missions, and we're out looking for other opportunities, and we'll be bidding on those. And what was the other part of your question?
I just wanted to know what your plans for more flights or more things with Wallops.
Well, and the other vehicles, we do have another, within our fleet, we have the Minotaur launch vehicle. That's where we take decommissioned ICBM motors that are in storage, and we create a space launch vehicle for the Air Force. And I believe there's one of those launching this October from Pad 0B. Pad 0B is the one just a little bit further south from our Pad 0A, and that's a solid rocket-fueled pad. And so I understand that Minotaur has a couple more launches that they plan to do out of Wallops, so we hope to win those missions and be launching more Minotaurs out of here. And we'd love to do other launches out of here. In the past we've done 7 Pegasus launches out of Wallops back in the day, and I worked some of those. So those are all different vehicles that we have within our fleet. They use a lot of common hardware and common software and share some resources in terms of people too.
Okay, next question.
Hi, Charlie Alejandro with the 411 Talk. I have a question for anybody on the panel. With the increased capacity for payload and cargo, is there any plans to expand the ability of students and schools to participate more in the experiments that are being conducted now?
From a space station program standpoint, we're open absolutely for increasing student participation on board the International Space Station. One of the goals in NASA is to inspire. And what a better way to inspire to develop an experiment that flies on board the International Space Station. So we're available for it. When it's ready, we'll fly it.
And I'll just add for our partnership with Virginia Space, the ThinSats that I talked about, those are, school children. There's 70 different schools that got involved. So it's really a huge footprint in terms of, student and participation per kilogram. I think it was amazing, the program that Virginia Space put into place, and we have a partnership with them. When we have excess capacity on the rocket, we'll be able to put those ThinSats on the second stage of the rocket and launch those. And I don't think we'll be launching them on NG-12, but maybe for NG-13, which would be in the next spring timeframe. So that's what I've heard from Virginia Space. We're excited to offer that up. I think this was a good trial run on how they get the schools engaged. There was a lot of I attended one of their sessions where they went to an elementary school and presented the project, and really got the kids enthused. So kudos to Virginia Space for really trying to dig deep into the school system and get kids excited at a young age.
And the only thing I'll add is it wasn't that long ago, and Kurt played a major role in the Pegasus program, but it wasn't that long ago when companies like what was Orbital Sciences Corporation at the time provided low-cost access to startup companies and smaller companies and commercial companies that were trying to get their stuff into space. And here we are now, we're offering access to space to students of all ages. And so that is extremely inspiring. And to be a part of that is very special. And when we think about the capabilities of us launching CubeSats directly off of Cygnus or the ThinSats off of Antares, how much access that provides to all sorts of STEM centers, schools, and other things. It's really inspiring. And so we need to get the word out, get CubeSat programs going in more and more schools and colleges, and letting people know that we fly to the space station twice a year. So we're ready to take you there, and it's a special thing.
Thank you. Next question.
Hi, my name is Emery Stagmer with Tomorrow.tv for the Northrop Grumman team. You've talked a bit about the future of Cygnus. Is there a future pre-planned improvements for Antares and any other missions besides Cygnus for the Antares launch vehicle?
Well, I think I mentioned earlier that starting with NG-12, we'll be flying a what we're called 230 plus. So NG-11 was 230. We're calling it 230 plus because it's really not that different, but it has some key enhancements. So it's mass fraction improvements on stage 1. For example, the heat exchanger on the engines. We don't use it to heat up our helium pressure and gas, so we've asked our vendor to not install it any longer. That saves a bunch of mass on each engine. The first stage I mentioned, we're going to add mass in 2 key locations, add more metal, but that's going to net us a bunch of performance by allowing us to not have to do the throttle notch at max Q. Second stage is going to get lighter. We're removing some insulation on the interior of the case. We are confident in doing that from the static fire and the flights we've done to date. And then the composite structures, we're redesigning them to collapse a bunch of structures into one singular structure that'll save the interface fasteners and other items. So yeah, those are the upgrades we're doing. It's going to net us a bunch more mass to orbit on the order of, I think it's 700 or 800 kilograms additional payload to orbit, to this low orbit. So that's a big pickup. We are bidding on other missions, and we hope to win additional business from NASA, other parts of NASA or Air Force. So we are pursuing those opportunities, or maybe commercial. So, but we haven't won any of those contracts yet. So we're focused on the CRS missions that we have on our manifest at this point. Sure.
Next question.
Alex Mankiewicz of the Zog 43 Rocketry newsletter. This is for Frank. Anticipating this fall, when we expect to have 2 Cygnus spacecraft in orbit simultaneously, let us know what is the level of preparation needed at the Dulles Mission Control Center? Do you need to bring in additional personnel, additional equipment, or are you good to go as you are right now?
So I think of it in a couple of ways. First, on the hardware side, we're upgrading our Mission Operations Center both at our Dulles facility and our backup center down in Houston to be able to have different computing systems that can command and talk to the two different spacecraft and receive the telemetry. From a personnel standpoint, when we're operating the 2 spacecraft in what we call a quiescent mode, either they're berthed to the ISS or they're just free flying and not much is going on, we can actually operate both spacecraft with the same team, and it's actually a relatively small team. At times of a real flurry of activity, so while NG-11 is flying around, but NG-12 is launching or rendezvousing, then we have the ability to have our Houston team, say, control and monitor NG-11, and we'll have the big team in Dulles in our Mission Operations Center there doing all the real intense work for the launch and the rendezvous. So we'll adjust the teams as we go, but the infrastructure is getting put in place to operate both spacecraft. The software has been updated, and so we're excited to be able to demonstrate the capability.
Okay, one more call for any other questions. Great. Thank you for joining us today for our post-launch news conference after a beautiful launch this afternoon. As a reminder, Cygnus will arrive at the orbiting laboratory early Friday morning, April 19th. At 4 a.m. Eastern Time, NASA TV coverage will begin with grapple expected at 5:30 a.m. and NASA TV will resume at 7 a.m. for the installation of Cygnus onto the space station for its 3-month stay. So please join us again on Friday morning, and until then, you can follow life and science aboard the space station at nasa.gov/station. So go Cygnus, go science.